Okay, so I'm going to finish up what we did here with implicit differentiation. I do kind of want to just go through the steps real quick one more time, and they're written in this box on your notes. But the first thing that we do is we differentiate, that's what this top D means, of the whole thing with respect to x, always differentiating with respect to x. So that means when we differentiate a y term, what do we got to multiply it by? Do you remember? dy over dx. It's like a little application of chain rule. Okay, when you take derivative of an x term, it's just like normal. Okay, and then you go through all the pluses and minuses, just separate out the terms. We did do another one. Oh, sorry. Let me finish what I was saying here. Once you've taken derivative, keep the dy over dx terms on the left, and then see how there's three terms? The way you get a single dy over dx is by factoring, and then your last step is to divide. Sometimes you do need to use product rule. Okay, so I want to erase this little bit right here. You have some on your assignment where if you're multiplying an x times a y, you're going to have to use product rule on those types of problems. And we're going to do one today that needs quotient rule as well. Okay, so let's look at number 3. We're just going to do 3 and 4, and that's it. So for number 3, first thing, always take derivative with respect to x. That's what d over dx says. And the reason we put parentheses around everything is so that we know we're deriving all the pieces. Okay, cosine of 2y. What's that derivative? Negative sine of 2y, right? Keep the inside the same, times, now we go derivative of 2y, which would be 2. And since I took derivative of 2y, then I write my little dy over dx. And that's all there is to do on the left side. So even though this is trig, there's a lot less steps. Okay, what about the right side? Just a 1. Do you need a dy over dx?
No.
No, you only do that when you derive y terms. Okay, now typically what we had been doing was we put a big box around dy over dx terms. Now some people were like, how do you know how wide this box should be? Like, where should I cut it off? So here's what I'm going to say about that. See how the dy over dx is being multiplied to the 2 and being multiplied to the negative sine y? So this is all a single term. If there had been something like a 2 minus this, well then I wouldn't box the 2, and there wasn't in this case, so I'm going to erase that. All right, now that term is already on the left, and there's only one of them. So we get to skip the step that puts everything on the left with a dy over dx, and we get to skip the factoring step. We get to go straight to dividing. Do you guys see what you need to divide? You want dy over dx by itself, so divide by everything else. So negative sine 2y times 2, both sides. Okay, and that's actually your answer right here. You know you have your answer when you have a single dy over dx on the left, and over here you only have x's and y's. You don't have to have both of them, but you shouldn't have like dy over dx equals something with dy over dx in it. Okay, what does this represent on this graph? What does that thing I boxed represent? Yeah, so what does that represent on the graph? The slope. Okay, this is like a slope. What happened here? That's weird. You're kind of like lagging a little bit. Okay, whatever. It's like it's Friday. I'm done. Okay. Yeah, it does. So this is representing slope. So if I wanted to know the slope at, say, 0, negative pi over 4, I would just plug those values in this case only for y, and that would help me find the slope. Okay? So that's what it represents. Let's look at number 4. What are we looking for on 4? What does that say? the double derivative. There's no shortcut to the double derivative. You just got to find the first derivative and then do it all over again. Okay, so I'm going to take derivative with respect to x of both sides of this thing. By the way, what is this thing? What shape does this make? There's no picture. It makes a circle. Some people remember this, some people don't. What's the radius of this circle? 5. I'm going to ask you more about that in a minute. It's not required to do the problem, but it's interesting. So, see that plus? Don't make this more complicated than it needs to be. Take derivative of x squared, take derivative, do a plus, take derivative of y squared, write an equals, take derivative of 25. Okay, so go ahead and do that part on your own. Okay, when you're done, I want you to look up at the board and see if you have what I have. Or, because what I've done is made the most common mistake, and you might have this on your paper. What did I do wrong? You're not supposed to have 25, because what's the derivative of 25? 0. Sometimes I make mistakes just because I'm rushing. This was intentional. I really want to bring this up. So many students make that mistake. You don't want to be that student. Okay, we're doing all this difficult calculus and then you forget that the derivative of a number is 0. Don't make that mistake. And you won't if you practice this enough. Okay, so then we're going to look at terms that have dy over dx in them. Yeah. Yeah, okay, so x squared, just normal 2x derivative. Okay, y squared, if I'm deriving with respect to x, okay, y squared, I derived the squared part of the shell, so it would be 2y to the 1 power. And since I took derivative of a y term, I got to go times dy over dx. It's like a little chain rule. Anytime you take derivative of a y term, times dy over dx. Okay, so I have this thing boxed. That thing is going to stay then on the left. So 2y times dy over dx equals, and then this 2x at the beginning, it needs to be moved over to the other side. And again, on this one, I don't have to do the whole factoring step. I can skip that. So go straight to the dividing. And so I have dy over dx equals, now I don't have to simplify, but because I have a whole nother derivative to do, if you can do an easy simplifying step, you should, because it's only going to make the next step easier. Okay, so what's the easy thing to do to simplify this? The 2's. Now, I couldn't do this if I was like adding or subtracting numbers after, okay? I can only do it because it's a simple negative 2x over 2y. So this right here, I'm going to circle this. It's not my final answer, but this is my first derivative. Okay, before we do the second derivative, I want to ask you, okay, this was a circle, right? Radius was 5, center at origin. Center is going to always be at origin, by the way. That's the nice thing about calculus. It doesn't have to be, but it will be. What if this was a different circle? And let's say instead of 25, it was, say, 36. How would that change this work? It wouldn't. Why? The derivative of a number is 0. So we can say now that all circles that are centered at the origin, which are the only circles we're going to do, will always have a first derivative of negative x over y. That is not something you need to memorize, but it's interesting to note. You're going to see a problem like this on your homework, and you might see one on a test. So if you do remember it, it's a nice way to check your work. I would still want to see your work on this. Okay, so that's half the problem, right? That's the first derivative. Okay, I'm going to switch colors up. I'm going to use green here. And I'm going to go ahead and rewrite the answer that we got. And I'm going to take a derivative again of both sides. So just like how I've done on every other problem, I'm going to do d over dx. What this stands for is the derivative of everything in the parentheses with respect to x. That's what that little dx means. So watch how this notation works out, and this is going to help some of you understand maybe why we use second derivative the way we did. Okay, in this case, this is going to be d squared y over dx squared. This was the notation I already gave you back earlier in chapter 2 for second derivative, and some of you are like, why is the squareds, why are they in the places they're in? Although I'm not doing d times dy, do you kind of see how that works out to be d squared y? That's why they've used the notation they have. This little dx, it's not dx times dx, but you can kind of almost, I don't want to put parentheses, but it's like squaring the whole thing. This maybe helps you understand why to use the notation the way it is. Okay?
So why is the bottom one not d squared also?
It's kind of, I hesitate to do this. Okay, we're going to put this in the temporary memory bank. Okay, just explain that. It's like that. That's really how I could have written this. You see that? But we're not going to write it that way because that's just not how you're supposed to write it. When you develop calculus, you get to decide how the notation is going to be. All right, so that's that. Okay, that's the second derivative. Earlier, you can even look on your last test. I used the notation d squared y over dx squared. It's just the notation for second derivative. It's the same thing as y double prime. It's just different notations. Okay, well, let's get to the right side. What rule do we need to use here? Quotient. You could actually do product rule here. Okay, it really wouldn't be that bad. You could move that y up to the top, but I would like to just go ahead and practice quotient rule here. So the denominator, I'm going to go ahead and do that first, all over the denominator squared. And remember, quotient rule is derivative of the top times the bottom minus the top times the derivative of the bottom. It's easy to focus on one thing at a time. We just don't have that luxury most of the time. We're going to be doing several things at once. Okay, how do I write the derivative of the bottom? Yeah, so I'm going to put a 1 in there. Do I need it? No. But just to be super clear to everybody. All right, and obviously we could clean this up a little bit, but we don't have to. The only thing, though, that I do have to take care of is this right here cannot be in my final answer. Your answer has to be just x's and y's and numbers and additions and subtractions and all that. So this isn't a crazy big next step. It's actually really easy. What is dy over dx equal to? We just found out earlier. Negative x over y. So watch what I'm going to do. I'm going to rewrite the problem. And instead of dy over dx, I'm going to write what it was equal to. Negative x over y all over y squared. And that's your answer, unsimplified. If all this unsimplified stuff is bothering you, don't worry. We will get to that. Right now we're focusing on the skills of getting the correct answer. Now my answer is just in terms of x's and y's. So I'm going to ask you the same question I asked earlier. What happens if we move this to another circle, say 49? Now we're doing a radius of 7. You guys told me correctly that the first derivative doesn't change. Does the second derivative change? No. So every circle will actually work out this way.
Where did you get the dy over dx from?
Because I took the derivative of the bottom. Right? In quotient rule, derivative of the top times the bottom minus the top times derivative of the bottom. When I took derivative of that y, I got a 1. And since I took derivative of a y term, it's dy over dx. Every time you derive a y term, you got to go times dy over dx. Okay, so that's it for today.